All right, hello everyone. This is a talk about Lustre high availability, and it's about a new system for managing Lustre high availability that we're developing at LANL, and that system is called Halo. I'm going to start by kind of reviewing the state of the art, what high availability in Lustre looks like today. And then I'm going to talk a little bit about why at Los Alamos we're not really satisfied with the status quo and why we're interested in making a new system. Then I'll introduce that new system, which is called Halo. I'll explain what it is, how it works, how you can use it, and then finally, if you're interested in trying it out yourself or getting involved in some way, I'll let you know how you can do that. All right, so I'll start off with just kind of setting the stage for what HA and Lustre looks like. If you've been a Lustre admin for a while, this section will probably entirely be review for you. But basically, the fundamental concept for high availability in Lustre is the failover pair. Most commonly, this is the architecture that's adopted, where all your servers come in pairs, where each server is physically connected to the same storage. And at any point in time, one of those servers can be serving that storage or perhaps a subset of that storage. Now, normally there would be a software solution that is used to kind of monitor and manage the file system and do power management of the nodes and to migrate services between the nodes and stuff like that. And Pacemaker is the standard software solution. It's what the Lustre documentation recommends. It's what most sites use, at least most sites that have their own on-prem Lustre installations. To summarize how Pacemaker works a little bit, there's kind of two main architectures that Pacemaker is used in. So the first one treats the entire file system sort of as a single cluster. So it's all kind of under the management of one service. It's one conceptual unit. Then the other common architecture is for every failover pair in the file system to actually be its own separate cluster. So here's a little bit more detail on those two architectures. This is the first one, where the entire file system is basically treated as one cluster. So the nice thing about this architecture is it's fairly simple and straightforward. It's relatively easy to manage. You kind of have a view of the entire file system at once. The unfortunate thing about this architecture is that it kind of performs badly. Once you get beyond like a couple dozen nodes in your file system, Pacemaker sort of slows down to a crawl, and it becomes difficult to manage. So because of that, people often turn to this other architecture where every failover pair in the file system is basically its own cluster. So you don't run into those performance problems here because your clusters are tiny. They're only 2 nodes each. The unfortunate thing about this architecture is that you lose the ability to get a sort of overall view of the entire file system state at once, at least within the Pacemaker framework. So you have to resort to writing scripts or layering additional tooling on top of your HA system if you want to manage the entire file system at once. So overall, I mean, both of those architectures do have their drawbacks, and I think overall Pacemaker is kind of a difficult system. So it's often said that Lustre has a steep learning curve, that it's intimidating to new admins, things like that. To be honest, in my personal opinion, I think Pacemaker is a very large part of that. Speaking from my personal experience when I began working as a Lustre admin many years ago, I personally found Pacemaker actually a lot harder to learn and to get experience with than Lustre itself. So I think it's really a serious burden for new Lustre admins. Some of the issues with Pacemaker, the diagrams on the previous slides are actually a little bit of an oversimplification. One thing that makes it difficult is there's multiple different front ends. You've probably used PCS commands. You may have used CRM commands. If you have a Lustre appliance that you purchased from a vendor, they may have their own custom front end. You may have even written your own custom front end at your site, I'm not sure. Pacemaker also is kind of maybe a little bit extreme in terms of adopting sort of a microservices architecture where there's like numerous separate daemons that actually make up the management service. So I feel like one of the big issues that we have with Pacemaker is it's opaque. And what I mean is it can be difficult to understand its decision-making process. You may feel that a failover is warranted. Actually getting Pacemaker to do a failover can be surprisingly difficult. On the other hand, you may think that everything's fine, but Pacemaker is shooting nodes and you're not really sure why. So, I mean, an experience that I personally have had multiple times is like, it's 3 a.m. I was called on site because a Lustre server crashed. I've rebooted the server. I've imported the Z pool. Maybe Lustre recovery is like partway through, and then like bam, Pacemaker shoots the node. I don't know why. From my perspective, everything was healthy, but now it's 3:30 a.m. and I'm waiting for the server to reboot for a second time. Z pool import Lustre recovery to happen all over again. So that kind of puts us in my opinion, just a sort of disappointing status quo. The reality is that it's pretty common for admins to just turn Pacemaker off when an outage occurs because they just know it's going to get in the way. And a lot of people just don't use Pacemaker at all because it's easier and more reliable to just manage the file system by hand. So I'm being awfully negative so far, and I'm not trying to say that Pacemaker is entirely bad. I actually assume that Pacemaker would work well enough for its intended use cases, but I think part of the problem here is that I think Pacemaker is actually designed for a very different type of system than Lustre. And kind of what do I mean by that? So to understand what I mean by that, so in a high availability system, there are really actually two classes of service. There's the management service, so that would be Pacemaker. And then there's the managed services, which are like the Lustre file system services. Now, Pacemaker is designed to make both of those classes of service highly available. So both Pacemaker itself, as well as the Lustre file system services, are supposed to be HA. Now, that sort of design may truly make sense for some use cases. I personally don't really think that's useful or necessary for Lustre. So first of all, it's pretty common to actually run Lustre file systems with only a single management node. Now, theoretically, Pacemaker can have a distributed management service where the management service itself is highly available, but since a lot of sites run it on a single node, that is not what actually happens in reality. Now, some file systems do use a pair of management nodes. Personally, I don't believe that actually provides that much value, but it is fairly common as well. Now, having a non-redundant management service sounds like a bad thing. I do admit it sounds like a bad thing, but I actually don't think it's a problem. With having a single management node. In all the years I have worked as a Lustre admin, I don't think I've ever experienced a production outage caused by a management node failing. So overall, I really feel the state of Lustre HA management currently is not ideal, and I think there's a real need for software that's designed specifically for the services that Lustre needs and kind of meets the actual needs of Lustre admins. And that's where Halo comes in. So Halo's a piece of software that we're developing at LANL. It's designed to kind of be a more admin-friendly system for Lustre high availability management. So it tries to be simple, only implementing the features that are actually useful to Lustre admins, transparent and unobtrusive so that it gets out of your way when you just need to do something. So what is Halo? How does it actually work? So Halo is organized into three main components. There's a management service, which is a daemon that runs on your single management node. There's a remote service that runs on all of the file system servers. And the management service, communicates with those remote services. It learns the status of the cluster, does power management, things like that. And then finally, there is a CLI utility that the admin uses to interact with the management service. So I'll go over some of the kind of design principles of Halo that are intended to keep it simple and sort of fit for its purpose. So like I said, Halo is designed around the reality that the management service is non-redundant. You just have a single instance of the management service running on a single node. And like I said earlier, I admit this sounds bad, but I think it's actually a good thing. And the reason it's a good thing is because it makes the system dramatically simpler. Not having to worry about having a distributed management service means we don't have to worry about distributed consensus and those sorts of complex issues. And for frankly a failure case that's so unlikely that I think it never happens probably in the average file system for the entire file system of that lifetime. I just don't see the value in complicating the management service for such an unlikely failure case. Another design principle of Halo is that it decouples the management and managed services. So what that means is the management service and managed services can be started and stopped independently. So suppose you are going to do some complicated manual action on your file system, like you need to do some failovers or service migrations by hand. If you just want to do that and you want the HA system to get out of the way, all you have to do is systemctl stop Halo. It will just stop the management service. It won't try to bring down the entire cluster. That's something that can be surprisingly difficult to accomplish with Pacemaker. Once you've done what it is you need to do and you're ready to start the automatic HA management again, it's just systemctl start Halo. It will figure out the changes to the cluster state that occurred while it was stopped. In terms of how does Halo actually do power management and how does it actually do resource management, it integrates with the existing OCF resource agent and fence agent APIs. So if you use Pacemaker at your site, you're probably already familiar with these programs, but we're not reinventing the wheel here. We're using those existing OCF APIs to do the actual resource and power management. Okay, so what if you actually want to start using Halo on one of your systems? How would you do that? So the first thing is setting up the configuration. The config file is a YAML file. It's designed to be hopefully easy to read and understand and edit by hand if you need. I'm not going to go into the details of all the fields in the YAML file, but basically it has information on what your resources are and what nodes they run on and such. Fencing and failover information is also in that YAML config. Now, normally you won't have to create a config file by hand. So if you already have a file system that has been stood up and is running, there's a command called discover. You give it a list of all the host names for your file system. It will SSH out to all of those nodes, and it will figure out what services are running on those nodes currently, and it'll create a config file based on the state that it discovers. So if you've already got a running Lustre file system, you can just use that command and get a config that matches its running state. So normally you won't have to create the config by hand. Okay, so you've created your config file. How do you actually start Halo? Normally you would manage it with systemd. So first you start the remote service on all your file system nodes. Then once it's started on all those nodes, you just start the management service on your management node. When the management service starts, it'll reach out to all those remote services. It'll try to figure out what file system services are running where. Anything that it discovers to not be running anywhere, it will try to start. Okay, so once you've got Halo running, I'm going to summarize kind of some of the main commands that you would commonly use. So probably the first one is status. You run it and it tells you the status of the cluster. So I've got a very small test cluster here. It tells you which host it's currently connected to, which resources are running on which nodes, and that sort of thing. Another common administration task is needing to trigger a failover. So if you want to trigger a failover by hand, the way you do that is with the fence command. So you give it the host name of the node that you want to power off, and then there's an optional reason field where you can say why you're doing it. That reason is persistently logged, so later, or maybe your coworker is taking over on call, they know why you did what you did. So in this sort of example, little tiny test cluster, I fenced MDS01, and then you can see after I did that, I ran the status command, and it tells me the resources that were running on MDS01 are now running, but failed over on MDS00. So Halo's trying to be conservative and not do anything that is too risky. So part of that is once the system powers off a node, it will not fence or power off that node again. So that's to try to prevent constantly powering off the same node in a cycle if there's some kind of persistent issue. So if you, as the admin, have determined, okay, that node is healthy now, I'm ready for Halo to kind of have full control over it again, you need to reset that node so Halo knows it can power it off again if it needs to. You do that with the reset command, and again, you can specify a reason that is persistently logged. A common thing that you might want to do is maybe some resource is currently having a problem of some kind, and you want to take some manual action on it. If you want Halo to basically stop managing a resource temporarily, you can do that with the unmanage command. You give the name of the resource, and again, you can specify a reason saying why you're doing it. Once you do that, you can do something like stop the resource for an extended period of time. You can manually fail it over to its partner node, whatever it is you need to do. Once you've done that and you're ready for Halo to begin management of that particular resource, you can have that resumed with the manage command. Another common thing is you have an entire node that is having some kind of problem, and you don't want to run any services on that node for some time. So if you want to prevent Halo from running any services on some node, you use the deactivate command. You pass it a host name, and then once you do that, it will not run any services on that node. If any services were running on the node at the time you issued the deactivate command, it will try to gracefully stop them and bring them up on the failover partner. And then again, you can undo that once the node is fully healthy again with the activate command. So in terms of the persistent state that Halo stores, Halo does not track or store the state of the cluster persistently. What it does store persistently is it stores a log of events that have occurred. So when the management service starts, it reads that log and kind of replays all the events that happened. And it does that to learn about things like, say you deactivated a node. If the management service restarts, when it comes back up, it should remember that that node was deactivated so that it doesn't go and try to run resources on it. So that sort of state is stored in that event log so that it remembers the things it needs to remember. But the actual state of the cluster, like what resources are running where, that's not stored persistently. That's dynamically figured out so that you can stop the service and modify the cluster state however you want and start it again without anything going wrong. Now, I'm mostly talking about HA clusters with failover pairs because that's kind of the interesting case here, but it's worth noting that if you have a cluster that does not have high availability and you just have, single servers with their own private storage, you can still actually use Halo on that sort of cluster. Obviously, it's a lot more limited in terms of what it can do. Like, it can't do failovers for obvious reasons. So at this point, it's mostly just like a monitoring kind of program if you use it in that capacity. I'm working on implementing a feature where it could determine that a node is unhealthy and automatically reboot it and bring up the services again. That's in the works, but not fully implemented yet. But yeah, you can use Halo on non-HA clusters too, but it's not as interesting in that case. Okay, so that was kind of a quick summary of what Halo is and how it works. But what if you're interested in trying Halo or getting involved in some way? So first off, Halo is open source. The repo is available online. You can check it out. It's written in Rust. I really did go to a lot of effort to make it accessible and kind of easy to understand. It's got a test suite. There's, I hope, good documentation. So I would, if you're curious about trying it, I would encourage you to check it out. Do have some patience because this is actually going to be the first time that anyone other than my coworkers at LANL have seen it. So there could still be gaps in the documentation and things that are unclear and that sort of thing, but if you find anything like that, definitely let me know. Something that I've heard a lot of people say over the past couple of years is like, oh, I really want to learn Rust, but I don't have a project yet to work on. If you're interested in learning Rust, or maybe you've learned Rust and you want a real-world project to contribute to, Halo could be a good choice. New contributors are very welcome. There are a lot of easy issues that people could work on. There are also more sophisticated things to still do. So reach out to me if that sounds interesting to you. In terms of what if you actually want to try using Halo at your site? So first off, I would say Halo, I would consider it experimental. We're working on getting it production ready at LANL, but we're not quite using it in production yet. Halo does support a sort of passive mode where it doesn't actually take any actions, but it will monitor the state of the file system. We are using it in production in that capacity, but once we are a little farther along with testing and being confident in it, we're hoping to move into using this in production at LANL soon. So basically, I would say if you're interested in trying a new approach to high availability and you're adventurous and willing to sort of be actively involved, I would love to work with you on getting Halo used at more sites. It'd be really great to have other sites using this because sometimes software projects that are only used in one site can die pretty easily. But I really think if we kind of collaborate and all work together on this, we can really, come up with a better solution for an area that has long been very painful in Lustre system administration. So yeah, if you're willing to kind of be actively involved with, reporting bugs and working with us at LANL and getting Halo production ready, definitely let me know. If you're interested in trying it, but you're not ready to, replace your known solution with something new and unknown, you can always install Halo alongside your existing solution in that observe-only mode and kind of get a feel for how it works without taking on too much risk. So finally, I would like to thank my coworkers and my management at Los Alamos for taking me seriously when I said I wanted to replace Halo. Or replace Pacemaker. So thanks to them. And yeah, that's all.
Hi, question. Is it fully ZFS bound or does it support all diskfs?
Yeah, that's a good question. As I mentioned on this slide, in terms of how Halo manages the underlying resources, it uses those OCF APIs. I realize these are a bit obscure. If you're not deep into Pacemaker, you might have never heard of it. But basically, any system that implements those APIs, Halo can manage. and LDiskFS qualifies. So yes, I would say at LANL we're, we almost entirely use ZFS. So all the real world experience comes from ZFS, but it can support LDiskFS. And if you have such a system and you're interested in collaborating, hopefully we could iron out any bugs that appear.
We are, yes.
Other than like real world experience, like what gaps are you aware of between Halo and Pacemaker? What would you like to see done before you say it's like feature complete and has parity?
Yeah, that's a good question. So first off, the biggest gap is one that I don't necessarily see myself ever closing, and that is that Halo is fundamentally designed around the failover pair architecture. Pacemaker is designed to support any conceivable cluster architecture, which is a good and a bad thing. I think that's great if you have an architecture that is more complicated than failover pairs, but it makes the system harder to use in its generality. But in terms of features, I would say I feel that all the kind of core features are implemented that we care about at LANL. You may feel differently based on the features you and your admins care about, but really the main thing is just gaining confidence that it's not gonna double import a Z-pool or things like that. Just kind of that real world testing for when things go wrong, making sure that it doesn't screw up. It's just testing it over and over again until we're confident in that.
Finish. So you mentioned about number of nodes. So I'm quite familiar with that because we don't run more than 8 nodes per cluster. So what's the scalability of Halo? That's one question I have. And another thing is, how does it do all the typical, consensus and fencing and all those things?
Yeah, so those are both good questions. So for the scalability question, I would say at LANL we've scaled it up to clusters in the kind of small tens of nodes, so 30 or 40 maybe. If you think about it though, I'm not actually that concerned about scalability up to much larger clusters because it's not actually really that part of a problem, I feel like. So I see no reason why it shouldn't scale to clusters with hundreds of nodes. And the reason is this is the kind of program that it actually does very little computing. Pretty much the entire time this program is running, it's actually just waiting for things to happen. So from a scalability point of view, I'm not that concerned. I don't really see any reasons why the underlying algorithms wouldn't scale up to hundreds or potentially even thousands of nodes, just because it's the kind of program where pretty much all it's doing is just waiting for things to happen. It doesn't really do much actual computing. As to the second question, so I feel like there are kind of two parts in that. There was how does it do consensus and stuff? So the answer there is it doesn't. So the decision on what resources run on what nodes is done entirely in that single instance of the management service. So we just basically sidestep that entire issue. There's no concept of consensus in Halo. That management service just decides based on its sole view of the state of the cluster. As for how failover actually happens, or how fencing actually happens, right now, like I kind of mentioned, I'm aiming to keep the system conservative at first. So currently the only situation that would actually result in fencing occurring automatically is a cluster file system node completely disappearing. So basically, if you get connection timed out errors and you just cannot contact the file system server at all, it will fence, it'll power off that server, it'll wait for affirmative confirmation that that succeeded, and then it will bring up the resources on the partner. So that's how that works currently.
Okay, thank you. That makes sense. So basically, even if cluster gets partitioned into equal parts, the management node decides where it's going to go.
Yeah.
But what if it is like, you lost management server, lost communication with a group of nodes, but not the other one, and it doesn't really know where it's actually running. Those type of situations. What happens?
So the way I would kind of think about it is like, I mean, like a partition would just be like the management server can't reach, one node potentially. So the nodes are organized into pairs. So that's our domain where like a resource can only run on one of two nodes in a pair. If the manager cannot contact in any way one of the nodes in that pair, it'll power it off. If it, for some reason, can't contact both of the nodes in the pair, well, it can't really do anything, and at that point, you just have a full outage. But, that would be the case with Pacemaker anyways. So, yeah, basically, if one node in a pair is gone, but the other one is around, you can still run services on the one that's around. If they're both gone, there's really not anything you can do based on the physical architecture that we're working with.
So back here in the corner, you may have just answered part of the question. I was going to ask if it sits on top of CoroSync or if the management service does all of it, all the pinging communication, and if so, is it using just the management Ethernet? Can be configured to use different networks?
Yeah, so it does not sit on top of CoroSync. It's very simple, I hope. It just uses, so specifically the way that the manager communicates with the remote agents is with an RPC protocol. Specifically, it uses Captain Proto RPC, which is a sort of newer protocol, but it's just basically like talking to them over TCP sockets. And it, right now the only signal that it uses to know that something has gone wrong is if you're getting connection timed out errors. So it's, it tries to be really simple in how it's designed in that sense. Does that kind of answer the question?
Yeah, that works. Thanks.
So quick question, you mentioned it runs with only 2 servers in a failover pair. If you had 4 or something in a quad, can you do that as well?
Currently, no. The failover pair concept is sort of a fundamental assumption. Now, if you're interested in using Halo, but you have a different architecture, we can have a conversation about what it would take to support that.
You're accepting patches, is what you're saying.
I mean,
Yeah.
sure.
Yeah, okay.
I viewed this as, trying to make a minimum viable product for the way we run Lustre at LANL. But, if you have a different physical architecture and you're interested, we can collaborate.
It sounds like, you're really not concerned about having a reliable management server to run this, but so with a Lustre deployment, a lot of people run an MDS co-located on an MGS. It sounds like you would absolutely have to recommend like a separate server from that, not run that on an MGS node, right? Because, like MDS services, might crash or whatever, and then you lose that management server. So is there, like, do you have deployment advice when using Halo? Do you really have a dedicated server? And you said it was like not doing a lot. Do you co-locate other services there? Is that a danger? Like what, just say more about that if you can. Thanks.
Yeah, so if I'm understanding the question correctly, and let me know if I'm not, but I kind of feel like you're talking about like 2 different things. One, you're talking about the Lustre MGS service, which I admit the terminology that I used is like arguably unclear, but that would fall into the category of a managed service within this context. So that would be running on one of the file system servers. From the perspective of Halo, it's just another service running on a server. Now, given the talks we've heard about, potentially allowing the Lustre MGS service to run on other nodes, that would be something that would take additional effort to support within Halo based on how it's currently implemented, but we could go there. But in terms of like deployment, so what we do at LANL is we literally just have a single management server that we use to SSH out to like all the cluster nodes. It's a very minimal server. It doesn't run any kind of like user-facing services or anything. It's literally just like running pacemaker and like SSH basically. Now, like I said, some sites do use a pair of nodes there. Halo, I said a fundamental design principle is that it is not a distributed service. If you have a pair of nodes, you could just, if you wanted to like kind of manage that, if one node crashes, you could kind of take on the, fencing yourself by making sure one node is powered off and then running systemctl start Halo on the partner. Like I said, there may be manual action there, but in my experience, it's not a failure case that is actually likely to happen over the lifetime of a file system. So personally, I'm okay with, there being some manual work in that type of situation. Does that answer your question?
It sounded like the manager node has no very simple requirements, no reliance on being anywhere near Lustre, so you could just run it on like a highly available VM if you wanted like hardware protection.
Yeah,
The VM,
absolutely.
as long as it has TCP connection into the things it's trying to talk to.
Absolutely. Yeah.
Okay.
All right, let's give a round of applause for our speaker.